Right, you are welcome back to Lisbon tutorial platform, and in this video we are taking a look at 4 other theorems of circle. We have already discussed 4 theorems. So we will cater for the rest of the theorems in this video, that is the 4 other theorems. Right, so you are officially welcome back to this lesson, and I urge you all to cooperate alongside. Right, so we are continuing from the theorem 5, that is the fifth theorem. And this theorem states that the angle a chord makes with the tangent to a circle is equal to the angle subtended by the same chord at the circumference of the circle. I'm going over again. The theorem states that the angle a chord makes with the tangent to a circle is equal to the angle subtended by the same chord at the circumference of the circle. We already know the meaning of chord. We said that chord is a line segment. Which end touches the circumference of the circle. So any line drawn that touches the circumference of the circle, or that has its endpoints touching the circumference of the circle, is termed as a chord. Let's look at the definition for a tangent. What is a tangent? Because we need to understand that particular word, the tangent. A tangent is any line that touches the circumference of the circle at only one point. Or a tangent is a line that touches a circle at only one point. Take note, a tangent is a line that touches a circle at only one point. That is the definition for a tangent. Okay, so let's consider the diagram below. We have a diagram, a nice diagram on the screen. Illustration 1. So look at this diagram carefully as we move along. We are going to use this diagram to explain the theorem stated. So in this diagram we have line TPS, and this line TPS is termed as the tangent to the circle. So let's explain. Now in the diagram above, P, N, Q, and R are points on the circle. P, N, Q, and R are points on the circle with center O. PR is the chord and TS is the tangent. So let me go back to the diagram. We are saying that PR is a chord, and line PS is a tangent. Line PS is a tangent. And this tangent, that is line PS, it meets the chord PR at point P. Also, the line TP or PT is also a tangent, and line PN is also a chord which meets at point P. So this is what we are saying. We are saying that the line PR is a chord and the line PS is a tangent which meets the chord PR at point P. Right. So let's continue. So as we said, we are saying that PR is the chord and TS is the tangent which touches the circle at point P. The line PQ is a diameter. the line PQ is a diameter. So when you go back to the diagram, you can see the line PQ. This is the line PQ. PQ is a diameter because it passes through the center of the circle. So it's a diameter. So we are saying that line PQ is a diameter of the circle. Note, since PQ is the diameter of the circle, it implies that angle PRQ is equal to 90 degrees. Since PQ is the diameter of the circle, it implies that angle PRQ is equal to 90 degrees. Therefore, angle PQR plus angle RPQ plus angle PRQ is equal to 180 degrees. Why? Because the sum of interior angles of a triangle is 180 degrees. There is a triangle formed here. Let me go back to the diagram. There is a triangle formed here. This is a triangle. We have triangle PQR. PQR is a triangle formed here. PQR. And the sum of interior angles of a triangle is 180 degrees. So since the line PQ is a diameter, we have learned in the previous theorems that a diameter subtends an angle at the circumference of the circle, and that angle is 90 degrees. Any angle subtended by a diameter of the circle at any point of the circumference is a 90 degrees angle or a right angle. So by that theorem, it implies that angle PRQ is 90 degrees. Angle PRQ is 90 degrees. So we can now sum the interior angles of this particular triangle PRQ. So that is what we are saying here in this equation. So we are saying that since PRQ or angle PRQ is 90 degrees, therefore angle PQR plus angle RPQ plus angle PRQ is equal to 180 degrees. It's equal to 180 degrees. This implies that angle Y plus angle Z plus angle 90 degrees is equal to 180 degrees. 180 degrees. Now, we are interested in angle Y plus angle Z. That means we are making angle Y plus angle Z the subject. So we get angle Y plus angle Z equal to 180 degrees minus 90 degrees, giving us equation 1 to be angle Y plus angle Z equal to 90 degrees. Angle Y plus angle Z equal to 90 degrees. Now, since the tangent TS is perpendicular to the diameter or the radius of the circle, it implies that angle RPQ plus angle SPR is equal to 90 degrees. It implies that angle RPQ plus angle SPR is equal to 90 degrees. Thus, we are getting angle Z plus angle F equal to 90 degrees. Thus, we are getting angle Z plus angle F equal to 90 degrees. So this gives us equation 2. This gives us equation 2. Now let's observe something here from equation 1 and 2. We can see that the right hand side of these two equations are the same. We have 90 degrees to the right hand side of the equation 1 and 90 degrees to the right hand side of equation 2. So it implies that the right hand side of these two equations are equal. So we can equate the left hand side. And by doing so, we are getting angle Z plus angle F equal to angle Y plus angle Z. That means we are equating the left hand side of these two equations. That is equation 1 and equation 2. Now, we can see that angle Z appears twice. One on the left and one on the right. So we can group like terms. We can group like terms. And by grouping the like terms, we are getting angle F is equal to angle Y. How did we get angle F is equal to angle Y? Because we subtracted angle Z from both sides. We subtracted angle Z from both sides. We subtracted angle Z from both sides. Or we grouped angle Z on one side. So we moved angle Z from the right hand side to the left hand side, making angle Z minus angle Z. So we get 0. We get 0 from that side. And that is why we had angle F is equal to angle Y. That is why we had angle F is equal to angle Y. Therefore, angle SPR is equal to angle PQR. Therefore, angle SPR is equal to angle PQR. Right. From diagram A above, from diagram A, we have angle S is equal to angle Y, and angle F is equal to angle S. From diagram A above, we have angle S is equal to angle Y, and angle F is equal to angle S. This implies that angle PNR is equal to angle PQR and is equal to angle SPR. Right. So, dear students, let's take our first example under this particular theorem. And we have a nice question on the screen. The question says that find angle TQS if angle QST is equal to 60 degrees and angle SQR is equal to 72 degrees. So watch the diagram carefully. Watch the diagram carefully. We are saying that angle QST is equal to 60 degrees. This is angle QST. We have angle QST. Angle QST is 60 degrees. And angle SQR is equal to 72 degrees. 72 degrees. Now, by this time, we have to differentiate between a tangent and a chord. We have to differentiate between a tangent and a chord. And in this diagram, the line P, and in this diagram, the line QS, and the line QT are chords. The line QS, line QT, and line ST, they are chords. Whilst the line QR is a tangent. Whilst the line QR is a tangent. Also, line PQ is a tangent. And it meets the line QT at point Q. Whilst the line QR, which is a tangent, also meets the line QS at the point Q. So take note of that. Right, so let's solve the question together. Let's solve the question together. Now, we are using the theorem discussed earlier to solve this particular problem. And the theorem says that the angle between the chord, that is called QS in this particular example, the angle between the chord QS and the tangent PR is equal to the angle produced by the same chord QS at the point T. So by this theorem, it implies that angle QTS is equal to angle SQR. Thus, angle QTS is also equal to 72 degrees. 72 degrees. So let me go back to the diagram and explain it better to you. Right. So in the diagram, the theorem states that the angle formed by a tangent and a chord is equal to the angle formed by the same chord at any point of the circumference. At any point of the circumference. So by this theorem, we are saying that angle QTS or angle STQ is equal to 72 degrees. It's equal to 72 degrees because the line QR is a tangent. The line QR is a tangent. And it meets the line QS, which is a chord, at point Q. The angle formed between this chord and the tangent is angle 72 degrees. It's angle 72 degrees. Now, the same chord that is called QS, the same chord that is called QS, subtends an angle at the point T of the circumference. Subtends an angle at point T of the circumference. And by this theorem, we are saying that the angle formed by this chord, that is the angle QTS or angle STQ, is the same as the angle formed between the same chord and the tangent here. That is what we are saying there. So it implies that angle QTS is also equal to angle SQR, which is angle 72 degrees. And that is what we are seeing in this particular equation. So it implies that angle QTS is equal to 72 degrees. Also, from the diagram, and in triangle QST, also from the diagram and in the triangle QST, we can see that angle TQS plus angle QTS plus 60 degrees sum up to 180 degrees. From the triangle QST, we see that angle TQS, angle QTS, and 60 degrees sum up to 180 degrees, because the sum of interior angles of a triangle is 180 degrees. Thus, we are getting angle TQS plus 72 degrees, which is angle QTS, plus 60 degrees equal to 180 degrees. So, we are now getting our new equation, that is making angle TQS the subject. We are getting angle TQS is equal to 180 degrees minus 72 degrees plus 60 degrees, giving us angle TQS equal to 48 degrees, giving us angle TQS equal to 48 degrees. So, dear students, we are on the sixth theorem. And this theorem talks about the properties of a chord. It talks about properties of a chord. So, we have some properties of a chord to be discussed here. And the first one that we are talking about is that equal chords subtend equal angles at the center of the circle. Equal chords subtend equal angle at the center of the circle. The second property also states that the line from the center of a circle perpendicular to a chord bisects the chord. So if you have a chord and we draw a line from the center of the circle to meet the chord perpendicularly, it divides or it bisects that chord, right? The next property says that equal chords in a circle are equidistant from the center of a circle. Equal chords in a circle are equidistant from the center of a circle. And the fourth one says that chords on a circle that are equidistant from the center are equal. Chords on a circle that are equidistant from the center are equal. So the vice versa of equation. So the vice versa of point 3 is the point 4. Alright. So, dear students, let's consider the diagram below. let's consider the diagram below. We are using this diagram to explain the 4 properties mentioned earlier. We are using this diagram to explain the 4 properties mentioned earlier. So we have a circle on the screen. We have a circle on the screen with center O. A circle with center O. The points A, B, C, and D are on the circle. A, B, C, and D are points on the circle. We have chord AB and chord CD. We have chord AB and chord CD. Take note, the line OA, OD, OC, and OB are radii. The line OA, OD, OC, and OB are radii. The chord AB subtends an angle theta at the center of the circle. The line AB, which is the chord AB, subtends an angle at the center, which is angle theta. Also, the chord CD subtends an angle at the points. Also, the chord CD subtends an angle at the center. And one of the properties of a chord says that equal chords subtends equal angles at the center of the circle. So, chord AB and chord CD are equal, and that is why we are indicated this particular sign. It means that the line AB and line CD are equal. And if they are equal, then automatically the angle formed or the angle subtended by these chords at the center of the circle are equal. So this angle is equal to that angle. That is angle COD is equal to angle AOB. And that is why we are seeing angle theta and angle theta here. Right. So let's continue from theorem 7. And this theorem talks about the tangent of a circle. Now, as I explained earlier, a tangent to a circle is a straight line which meets the circle at one point only. Okay. The tangent to a circle from an external point are equal in length. The tangents, we are talking about 2 tangents, and that is why we have made it plural. So the tangents, that is 2 or more, or more than 1. The tangents to a circle from an external point are equal in length. That is one property of a tangent. The tangent is perpendicular to the radius or the diameter at the circumference of the circle. The tangent is perpendicular to the radius or the diameter at the circumference of the circle. So whenever we draw a tangent to meet the radius or a diameter, the angle formed between the tangent and the radius or the diameter is 90 degrees. So that is the meaning of this particular statement. That is, the tangent is perpendicular to the radius or the diameter at the circumference of the circle. And this gives us another property of a tangent. Also, the line joining the external point to the center of the circle bisects the angle between the tangents and the radii drawn to the point of tangent. So this is another property of a tangent. We are saying that the line drawn or the line joining the external point to the center of the circle bisects the angle formed between the tangents and the radii drawn to the point of tangent. So we have 4 theorems. We are saying that the first one says that the tangent to a circle from an external point are equal in length. Other ones say that the tangent is perpendicular to the radius or the diameter of the circle. and we have the line joining the external point to the center of the circle bisect the angle between the tangent and the radii drawn to the point of tangent. So these are some few properties of tangent. These are some few properties of tangent. Let's consider the diagram below. So we have a nice diagram on the screen. We have a nice diagram on the screen. Now, the line AC and the line AB are tangent to the circle. The line AC and AB are tangents to the circle. They meet the circle at the point C and B respectively. They meet the circle at the point C and B respectively. And one property states that a tangent is perpendicular to the radius or the diameter of the circle. We have the illustration here. The line AC is a tangent and the line OC is a radius. The line AC is a tangent and the line OC is a radius. They meet at the point C on the circumference of the circle. So the line AC is perpendicular to the line OC, and this explains the property discussed earlier. That is, the tangent is perpendicular to the radius or the diameter. So the angle formed between the radius and the tangent is 90 degrees. 90 degrees. The same thing applies to the tangent AB and the radius OB. So we have radius OB and tangent AB. They form an angle of 90 degrees, or they are perpendicular. The line AB, which is the tangent, is perpendicular to the radius OB. Alright. We also made mention of other property. We state that the line joining the external point to the center of the circle bisects the angle formed by the two radii and the tangents. So the angle formed by the two radii here are radius OC and radius OB. The two radii here are radius OC and radius OB. And so the angle formed between these radii and the tangent of the circle So we have this particular angle formed by these radii, that is radius OC and radius OB. So we have an angle here formed by these radii. So these properties say that when a line drawn from the external point meets the center of the circle, it bisects the angle formed here. This means that it divides the angle into two equal parts. So if the angle here is Q, it means that the angle here is also Q. So these are some few properties that we discussed under the tangent to a circle. Right. Okay. So I've explained all this. But let me go over. We said that from the diagram, the lines AC and AB are two tangents from the point A, which touches the circumference of the circle at point C and B respectively. Note 1. The line AC is equal to line AB. So this is the explanation of the first property that we talked about, that the two tangents are equal in length. This means that the line AC, that is the tangent AC, is equal to tangent AB. And 2. Triangle ACO and triangle ABO are right angle triangle. Triangle ACO and triangle ABO are right angle triangle. Therefore, angle ACO is equal to angle ABO, and which is equal to 90 degrees. 3. The line OC is equal to the line OB. These lines are radii. these lines are radii, and radius are equal in length. Radius are equal in length. So line OC, which is radius OC, is equal to radius OB. 4. Angle CAO is equal to angle BAO, and angle AOB is equal to angle AOC. So I have explained all this. In the previous slide. Alright. So dear students, this is the last theorem that we will talk about under the theorems of circle. So we are on the 8th theorem. And this theorem says that equal chords or arcs subtend the same angles at the circumference of a circle. Equal chords or arcs subtend the same angles at the circumference of a circle. So take note, this is the 8th theorem. Now we have a diagram on the screen. A nice diagram. Now C, B, A, F, E, and D, they are points on the circle. And from the diagram, line AB, line FE, line ED, and line BC, they are chords. Chord AB is equal to chord FE. So you can see from here. This signifies that the line AB and line FE are equal. Alright. So from the diagram, AB and EF are equal chords. This implies that angle ACB is equal to angle EDF. And therefore, angle A is equal to angle B. So this diagram explains the 8th theorem, which states that equal chords or arcs subtend the same angles at the circumference of a circle. So we have chord AB and chord FE. These chords are equal, and so the angles subtended by these two chords at the circumference of the circle are equal. So the chord AB subtends an angle A at the circumference of the circle at the point C, and the chord FE subtends another angle, or subtends an angle at the circumference of the circle at point D, which is angle B. Since the two chords are equal, it implies that the angles subtended by these two chords at the circumference of the circle are also equal, and that is what we have explained here. Alright, so dear students, this brings us to the end of our lesson for today, and I thank you for making time with us from the first lesson to this particular lesson. Thanks for watching, and I am pleading that you subscribe to the channel so that you will be updated with the subsequent videos.